Let A be a 3 cross 3 matrix such that determinant of adjoint of adjoint of adjoint of A, this is 81. If S is set of all integers n which satisfies this equation, n belongs to Z, that means n is integer, and it satisfies this equation that determinant of adjoint of A that raised to n minus 1 square by 2, this is determinant of A raised to 3n square minus 5n minus 4. Then we have to find the value of sigma n belonging to S, determinant of A raised to n square plus n. So basically in this problem, first we have to find all the integral values of n which satisfies this equation, right? And for that we need to use properties of adjoint of a matrix. So we know that if we have determinant of adjoint of any matrix and this adjoint is given a number of times, then for this we have a standard formula that this is determinant of A raised to n minus 1 and this raised to k, where n is the order of matrix. For example, here the given matrix is 3 cross 3 matrix, so n will be 3. And this k is the number of times that we have adjoint. For example, here we have adjoint 3 times, so therefore this k will become 3. And this is given as 3 raised to 81, so this we can write as 3 raised to 4. Now determinant of A and this raised to n minus 1, so n is 3, that means n minus 1 will be 2, and adjoint we have 3 times, so 2 raised to 3, right? K will be 3 and n is also 3, so 2 cube, that will be 8, and this is 3 raised to 4, right? So determinant of A raised to 8, this is 3 raised to 4. So from here you can write determinant of A as plus minus root 3 or determinant of A square as 3. So that will be the determinant of given matrix A. Determinant of A is plus minus root 3 and determinant of A square, this is 3. Now let us try to find the value of n using this equation, right? Let us try to find the set S because n is all the elements of this set S, right? N belongs to S. So now let us try to find S. For that, again, we are going to use the same formula that determinant of adjoint of A. So this will be determinant of A raised to n minus 1. Now because n is 3, n minus 1 will be 2. And here we have adjoint 2 times. So that means if I use this formula that n is 3 and k is 2, right? So n minus 1 will be 2 and 2 raised to 2, so that will be 4, right? So determinant of adjoint of A for this 3 cross 3 matrix, that will be determinant of A raised to 4 and this raised to 1 by 2 into n minus 1 square. And on right hand side we have determinant of A and this raised to 3n square minus 5n minus 4. And now as you can see that for these two sides the base is same, it is determinant of A, so therefore we can equate the exponent. So 4 raised to 1 by 2 into n minus 1 square, so this will be nothing but 2 into n minus 1 square, and n minus 1 square means n square minus 2n plus 1, and on right hand side we have 3n square minus 5n minus 4. So 3n square minus 2n square, that will give us n square, minus 5 plus 4, so that is minus n, and minus 4 minus 2, that is minus 6, this equals to 0. From here clearly you can see that factors will be n minus 3 and n plus 2. And if this is 0, so from here we are going to get two different values of n. We'll get n as minus 2 and plus 3, and both of these are integer only, right? So that means here our set S. Now we are in a position to write the set S. S will be set of these two elements. In set S, we have minus 2 and plus 3, right? This is our set S. Now finally we need to calculate this one. We have to find determinant of A raised to n square plus n, and n belongs to S. There are two elements in S, so therefore in this summation there will be two terms. The very first term will be, now we can write the answer. The very first term will be determinant of A raised to n square plus n, and in place of n we can take 3. So if I take n as 3, 3 square will be 9 and 9 plus 3, that will be 12. Plus second term will be determinant of A. Remember here we have this property that if I have determinant of a raised to n. So we can take that exponent outside and we can write in this form that is determinant of a raised to n. Exponent we can take outside the sign of determinant. So determinant of a raised to 12, this when we'll take n as 3, and if I take n as minus 2, then we'll get minus 2 square 4, 4 minus 2, that will be 2. So this will become determinant of a square is 3. So determinant of a raised to 12 means square raised to 6. So we have 3 raised to 6, and then determinant of a square, this is 3. 3 raised to 6 will be 27 square, which is 729 plus 3. So that is 732. So therefore the correct answer for this problem will be option B. Right? This was a very interesting problem from the simple concept that if I have determinant of adjoint of a matrix and adjoint is given k times, then for that we have this standard formula determinant of a raised to n minus 1 raised to k, where n is the number of times we have adjoint and n is the order of matrix. So using that standard formula, first we calculated determinant of a square, then by equating the exponent we got two values of n, and that means this set is, this was set of minus 2 and 3, and finally we had to calculate this one. So the right answer for this problem is option D.